This is Activity 4, Changing Blocks from Lesson 2, Keeping the Equation Balanced, and Unit 4, Linear Equations and Linear Systems. And this is a revised version of Activity 4. In this activity, you're given a balanced hanger and you're asked to take away or change, actually, the number of shapes in this hanger and keeping it balanced as you do that. So you can add shapes or subtract shapes away, but the idea is to keep the hanger balanced. So we could take an equal number of the same shape away from each side. If we do that, we know that we're removing the same weight. So if I take 2 squares away from the left, I'm going to take 2 squares away from the right. So that is an equal weight. So this hanger is still in balance. If I take 2 circles away from the right, I'm going to take 2 circles away from the left. So this hanger is still in balance. And now I know that 4 of these triangles is equal to 2 of the squares. That means 1 square is equal to 2 triangles, because 4 triangles divided by 2 squares is 2 triangles for each square. So 2 triangles for each square. So now I can take away the same weight, although they are different shapes. So if I take away 2 triangles from the right and 1 square from the left, I'm taking away the same weight from each side, although they are different shapes that I'm removing. So I'm keeping this hanger balanced. Now I could also add an equal weight to each side. So it just says change the number. It doesn't say whether to add or subtract those weights. So in this case, I'm just going to make this up. I'm going to say that 3 red circles is equal to 2 pentagons. And so if I know that and I'm defining that, I can add 3 circles to one side and 2 pentagons to the other side, and that will keep this hanger balanced. So 3 circles, 2 pentagons, and this hanger is still in balance. So although I'm adding different shapes to each side, I'm adding the same weight. Now as an example, let's assign some weights and see what happens. So let's make the triangles 1 gram in this case, the square 2 grams, and the circles and the pentagons, I'm going to use a multiple of 6 because I want the weights to be whole numbers. So if I assign 3 grams for the circles, then 3 times 3 is 9 grams for the pentagons. So this would not be a whole number. You can still use it. It would be 4.5 grams for each pentagon. But if we go to a multiple of 6, so 1 times 6 is 6, that would make each of these 2 grams. I can't use that because I already used the square for 2 grams. So 2 times 6 is 12. That would make each of these circles 4, and that's what I ended up using. So if each of these circles are 4, the square is 2, that's 14 grams or 14 units on the left side, and 12, 13, 14 on the right side. I could make the total for the circles on the left and the pentagons on the right 3 times 6 or 18 units. That would make each of these 6 grams or 6 units, and that would make each of these pentagons 9. If I made it 4 times 6 or 24 units, that would make each of these 8 and each of these 12. So I'm using multiples of 6. Now if I'm not that concerned with assigning whole number weights to each shape, I could use anything over here. And let's say I call these 5 grams. That would be a total of 15 grams for the circles. That means the pentagons would each have to be 7.5 grams. If I made these 10 grams for each circle, these would be 30 grams. That would make each of these 15, and 30 is a multiple of 6. That's why both of these are going to be whole numbers. So you could use anything, play around with the numbers, see what you come up with.